Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we are going to solve university question paper under the subject Operation Research. Again, a very important video for all the TYBMS SEM6 student. This is going to be the part 1 of our video series based on solving April 2024 question paper. So let us see what all question were appeared in this particular question paper under the first question, that is question number 2, and let us see how to solve them in the most simplest manner. Okay, first question. A company manufactures two products A and B. To manufacture one unit of product A, 1.5 machine hours and 2.5 labor hours are required. And to manufacture a unit of product B, 2.5 machine hours and 1.5 labor hours are required. In a month, 300 machine hours and 240 labor hours are available. Profit per unit is of A is 50 and B is 40. Formulate LPP. Now, when such question is given, let us see how to solve it. Okay, so first we'll create a rough draft of the table, what all things have been given. So in the question they're saying there are two product A and product B. So we written here A and B. Okay, then they are giving you some itineraries, as in they're going to compare based on machine hour and labor hours. So I'm writing here, we have machine hour and labor hour. In the question is given that product A, in order to manufacture product A, 1.5 machine hours are required and 2.5 labor hours is required. Similarly for B, if you look in the question given, 2.5 machine hours and 1.5 labor hours. Okay, then it is given that in a month in total 300 machine hours are there and 240 labor hours are there. So we write less than equal to 300 and less than equal to 240. Okay, and they are giving you the objective function of maximization. They tell you the profit. So they are giving you profit is 50 for A and 40 for B. Okay, this is all what they have given us. So we'll start off with let the number of units to produce be x1 and x2. Okay, so that is basically our rough draft that we have created. This is all what is given in the question. Now let us see how we formulate it. Okay, so we will start number 1. First is always decision variable. The first heading we'll have to always note down as decision variable. So I'll write here decision variable. In decision variable, we will have to identify. We have to first put it in variable form. So we'll say let x1 equals product A and x2 equals product B. Second, we have objective function. In the sum, they had told you they have spoken about profit. So profit is always maximization sum. So it is max z. Okay, z is that for. So maximization problem sum where we have 50 x1 and 40 x2, the profit. So 50 x1 plus 40 x2. Third, subject to constraint. Okay, subjects to constraint. Here the equation, we'll have to build an equation. So this is like a first equation and a second equation. So it will be 1.5 x1 plus 2.5 x2. 1.5 x1, 2.5 x2 is less than equal to 300 as our first equation. 2.5 x1 plus 1.5 x2 is less than equal to 240 is the second, and we have to sum up stating that x1 or x2, they will always be greater than or equal to 0. They can't be negative. Okay, so this is basic ideology. And now last statement, therefore we just have to put up in LPP format. So therefore the LPP can be formulated as max z is equal to 50x1 plus 40x2. I'm just taking it from here. We just have to make consolidated. Subject to constraint. One point five x1 plus 2.5 x2 less than equal to 300. 2.5 x1 plus 1.5 x2 again less than equal to 240. Last x1 comma x2 is greater than equal to 0. Okay, so this is how you all had to solve the very first sum, question number 2a, which was based on formulation of LPP program. Chalo, you all can go through it once. Okay, now let us see the next question. Okay, the second question is, we'll read it first. It's given that solve the following LPP by simplex method. Maximize z is equal to 50x1 plus 20x2 subject to constant. They're giving you two equations and then they said x1 comma x2 is greater than or equal to 0. So now let us see how to solve the sum based on simplex method. So whenever simplex method ka sum is given, the first thing that you all need to do is first note down the objective function and subject to constant. So we'll start. Now here it is giving you max the objective function maximization sum. So max z is equal to 50x1 plus 20x2. Now there are two subject to constant which are given to you. So we'll have to prepare two slack values in this, plus 0s1 plus 0s2. Those are called as slack value because there are two two values or two equations have been given and we'll have to put two dummies there. Subject to constraint. Okay, now subject to mein there are two equations. The first one was 20x1 plus 10x2 plus s1. We put here slack value 1 which is equal to 500, and second equation is 50x1 plus 50x2. Here we put the second one, s2 is equal to 300. So slack values we have to add up extras in the. Okay, so once we have this, we'll start with the first simplex table. So simplex table 1. We'll first note down the column. This is something called as Cj. Okay, we have a C, we'll have X, B, we have something called as Zj and change, which is Cj minus Zj. Okay, now first step. Cj represents your maxima, your objective constraint. So whatever values have been given objective constraint, we will note down that. Here I'll just put that x1, x2, s1, s2. Okay, chalo. X1 was 50 given, x2 का objective function 20, and then we have 0 and 0. This is nothing but a retention ratio. Okay, I'm just writing a ratio. This column is for basically the ratio part which will come out. Okay, starting में the C values will be 0. X may we always write the the slack value name S1 S2. B is the total of both those equations, so we have 500 and 300. Okay, this is how it looks. Now we'll fill up the details which are given in our equation. So for x1 the value is 20, 10. S1 mein there is an S1, so I write that as 1. S2 is not available here, 0. Same for the second, it is 50, again 50. S1 is not available, 0. S2 is there, so 1. Okay, so with this we were able to fill this table. Now first step, after filling up the primary data in the table, the next step is first we need to find Zj. So now in order to find Zj, we'll have to use a formula. Okay, so let us see that formula. So I'm putting another sheet in front of you. The formula to find Zj is equal to C, those are your column values, into each variable columns. Okay, into the value of each variable of the column. So for example, the first value of Cj. Okay, I'll put it here so it is visible. I'm putting the equation in because this is how we require. Okay. So chalo, we'll start off now. See how we do. For x1, okay, we have to fill it this way: x1, x2, s1, s2. So for x1, to find the value of zj, see how we have to solve it. C is 0. Okay, and each column ka variable, so you have to multiply them. So 0 into 20 plus 0 into 50. So it becomes basically 0 into 20 plus 0 into 50 eventually comes to 0. The first value is 0. Again 0 into 10 plus 0 into 50. 0 into 10 plus 0 into 50, again that comes to 0. Third, for S1, again 0 into 1, 0 into 0. 0 into 1 plus 0 into 0 is again 0. And last, 0 into 0 and 0 into 1 is again 0. So eventually in a first simplex table, the first table mein Zj will always be 0. Okay, 0, 0. Okay. So that's the first thing that you all had to find using this particular formula. So chalo, we filled that up. Now we need to find the next thing, change, which is Cj minus Zj. So 50 minus 0, 50. 20 minus 0 is 20. 0 minus 0, 0. 0 minus 0, 0. Okay. So now see how this is very important. See the steps. Okay. Once you all have done with this table, now comes the actual little careful part which you'll have to remember. How to solve this further now? First step. Select the highest value from the change. So here the highest value is 50. So so this becomes basically our row that we have to remember. This is our key row. Get the highest value. Okay. Once you get the highest value, okay, once we get the highest value, now the next step what you need to find is the ratios. Now how to find the ratio? I'll note down the formula here. Ratio ka formula is equal to value of b divided by the key column. Okay. So now our key column, okay, was our column. So our key column ka value came out to be 50 because this is a key. Okay. So b value divided by, so it will be 500 for S1. Okay, for S1 ka ratio mein, okay, for S1 ka ratio mein, the value of b was 500 divided by okay, divided by the key column. So this is a key column. Key column ka value is 20. So it will be 500 divided by 20, which comes to 25. 0, 0 cut, 2 ones are 225s are. Similarly, for S2, 300 divided by 50, which comes to be as 6. So my ratio may here also you can show the same thing. Okay, you can show here this is 500 divided by 20, which came to be 25, and 300 divided by 50, which came to be 6. Again, first step in change, you need to get the highest value, mark that column. But now when you're going towards the the row side, the lowest ratio among the two, 6 is the lowest ratio. So this will become your key row. So we mark this is our key row. Okay. So now once you all have done this, okay, the key element, the middle of intersection point is your key element. So we have to note down three things. Our key column, which was a key column x1, which is a key row was s2. It means s2 will get replaced by x1 in the next step. Okay. And key element is the midpoint, that is 50. Very important point. Okay, now these three things are very important. What do you mean by this? Your s2, okay, this key row will get replaced by x1. Okay, so this is like the first part of the sum that we have done. Okay, we got the table, we got these elements. Now we need to create a new table using new values ke sath. Okay, so chalo, I'll be replacing this with a new table now. So this is very important. You'll first note down this because this has to be there in your book first. Okay, while solving, because now when we'll create the second table, we have to keep this table in mind. Okay, all these values. Okay, so I have prepared another table. We will note down this as simplex table 2 now. Same order, Cj Okay, whatever values were there under CJ, so similar values. So here the CJ values were 50, 20, 0, 0. So same thing comes here, 50, 20, 0, 0. Okay, these are your ratios. Okay, here you have C, X and B. Okay, we'll just keep up to this point now here, and now we'll have to make the new changes here. Okay, now look at this very carefully. I'll just compare the first table with the second table. Your S2 will get now replaced by X1. So S1 के लिए there's no issue, so I'm writing it as it is. This was 0, so 0 S1 500. Okay, but values I will wait now. I'll just write S1. For S2 it has been replaced by X1. Okay, it is being replaced by X1, and X1 ka the element, the key value was 50. So we'll write this here as 50. Okay, again this is same thing, Zj, and change is nothing but Cj minus Zj. Now we need to fill up all other values. Okay, now in order to fill the values, now we'll have to use some different formulas here. Okay, so remember in this case, these are your key elements, the row and column, and the other ones also available which are not the key ones. Okay, so but we have to get the new values now. So let us see how we have to get the new values using certain formulas. Okay, first thing, for key values, okay, the one which already were marked, so the formula is new values is equal to old value divided by the key element. Key element ka amount was 50 that we had already found in the first step. Okay, so in x1 is the new, it was the key one. Okay, this was the one which was the new, it got replaced. So this is for the key, and the values to get it, let us see how to get those values. First, the very first value given, the old table, let us see the old table first. The very first value was 300. There is 300, 50, 50, 0 and 1. 300, 50, 50, 0, 1. This was a key row. All these values will change now. So 300 is the new value, it was the old value. So in that case it will be 300 divided by the key element was 50, which came to be 6. So my first value will be 6. The second amount was 50. So 50 divided by 50, value is 1. Again, we have the next value as 50. So 50 divided by 50 is equal to 1. Next was 0. 0 divided by 50 is 0. Okay, and for last, so basically this was like x1, x2, s1, and now for s2, I'll write here, this is x1, x2, s1, s2. Okay, for s2, wait, this was x1, x2, s1, and for s2 it was 1. So 1 divided by 50, so we keep this as 1 divided by 50 as it is. We can get those values in this fraction form. Okay, so chalo, for the key row we have changed all the values. Now for the other one, the one in which there was no key. Okay, so for the non-key values, how to get those values? So again, a different formula. The formula is new value is equal to old value minus the corresponding key column value into the new value of the key row. Okay, so a little bigger formula as compared to the first. So chalo, let us see how we inculcate that. Okay, I'm taking the old ka value also in front of you. This is the old table. Okay, I hope it is visible. Yes. Chalo. So now see how the old value, the formula states old value, which is 500. So I'm writing here. First we are trying to find for B. Okay, so B ka old value was 500 minus corresponding key column value. Now corresponding key column is this, so key column ka value is 20 into the new value of the key row. So new value of the key row was what? In that case it was the new value came here. So B ka new value is 6, so into 6. So the value what we got is 500 minus 20 into 6 is 120. 500 minus 120 is 380. So here we get the value as 380. Same way for x1. Okay, so I'm writing here 500 minus 20 into 6, which is 380. So we wrote the value as 380 here. Second value, second is 20. So I'm writing here 20 minus corresponding key column का value is again 20 into the new value which was 1. So into 1. So 21 to 1 is 20. 20 minus 20 is 0. So here x1 ka value will become 0. Same way for x2, old value was 10 minus corresponding key value is 20 into the new value 1. So 10 minus 20 is negative 10. So I'll write here negative 10. Next 1. So x1, x2. For s1 the value is 1. So 1 minus 20 into the new value is 0. So 20 into 0 is 0. 1 minus 0 is 0. So s1 ka value is 0. Last s2, old value was 0. So 0 minus 20 into the new value which is 1 upon 50. So I wrote here 1 upon 50. Okay, so 20 into 1 upon 50, 0, 0 get cut. So that's 2.5. 0 minus 2 upon 5 is negative 2 upon 5. So write this as negative 2 upon 5. Okay, so this is how you all had to get those values. So chalo, all the stable ka value we have already found. Chalo, now I'll move this. So now let's start with this, solving this part of the table. Now first thing, we need to first again solve the zj. Now zj ka formula will be again similar. Okay, it would be c into the variable, so 0 into 0 plus 50 into 1, so that becomes 50. 0 into 0 plus 50 into 1 is again 50. 0 into 0 plus 50 into 0 is 0. 0 into negative 2.5 plus 50 into 1 upon 50. So 50 into 1 is 50. 50 upon 50 is 1. Now we need change, that is c is j minus zj. 50 minus 50 is 0. 20 minus 50 is negative 30. 0 minus 0 is 0. 0 minus 1 is negative 1. Now the rule comes. This is the most important part. Okay, we will say that since now final answer may, you should have a negative value. If you get a negative value, the solution is optimal. If you do not get a negative value, then we have to solve the third simplex table. Since here we have negative value, so we will write since there is no positive value in change, therefore it is an optimal solution. Therefore only x1 was selected, so x1 ka value was 6, so therefore x1 is equal to 6 and x2 is equal to 0 because x2 was not to be replaced here. Therefore final answer max z, which was 50 x1 plus 20 x2, my answer for that will be x1 is 6, so 50 into 6 plus 20 into 0, that comes to 300. Okay, so that's our final answer. Simplex value is 300. Okay, so this is how you'll have to solve the later part of the simplex table. Chalo, you all can go through it once with the simplex problem has been completed. Okay, now let us see the next sum. Okay, the next question was question 2c. I'll read the question once. Solve the following LPP by graphical method. Maximization Z is given to us, subject to constraints have been given to us. Okay, chalo, let us see how to solve this particular sum. Okay, when such kind of question is given, they are giving you the max, they are giving you just subjects to constraint. So first take the subjects to constraint and start boxing it out to find the coordinates. Okay, so first step, the very first equation was 2x1 plus 5x2 is less than equal to 16, but in order to solve we'll take it as equal to 16. Okay, now we'll create a table x1 x2 x1 comma x2. Okay, Now very simple, whenever such equation is given, first always take x1 as 0, next take x2 as 0 to get the coordinates. So if I take x1 as 0, 2 into 0 is 0, so we get 5x2 is equal to 16. Okay, suppose if I have to solve this, it will become 2 into 0 plus 5x2 is equal to 16. Therefore 5x2 is equal to 16 because that's 0. Therefore x2 is 16 divided by 5, which comes to 3.2. So here we get the value as 3.2. So my first coordinates are 0 comma 3.2. Same way I'll take x2 as 0 now. If I take x2 as 0, I get 2x1 is equal to 16. So x1 is equal to 16 divided by 2, which comes to 8. So 8 comma 0. Same way we'll have to do for the second equation only, but second equation is a smaller version they are given. They just gave us 6x1 is equal to 30. So this is nothing but x1 is equal to 30 divided by 6, which is 5. I got those coordinates which I wanted. Now let us see how we plotted here, okay? So x and y, so I'll write here, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. This is x1, this is x2. First pointing, x is 0 and 3.2, so I'll mark somewhere here 3.2. Okay, x is 0 and y is 3.2. So next is x is 8 and 0. So those are my point. I will make a line passing through it now, or joining those 2 points. Okay. Second is directly x1 is equal to 5. So x1 is equal to 5. It will be a parallel line to y axis. But x1 is 5, but y is 0. Okay. So I'll pass it through. Since it is a maximization problem, so our feasible region. So now see, these are the point A, B, C, and O. I'll keep this as O. These are your point. Our feasible region is the middle part. Since the maximization sum, so anything which is under the closed enclosed area, that is our feasible region. So now the coordinate for the first A ka coordinate is 0 comma 3.2. B, we have to be not, we are not sure about it because we don't have the exact graph. Okay, so we keep this right now. C is 5 comma 0 and O is 0 comma 0. So now just to find this particular value, okay, just to be sure what the value is, we will solve that particular part. Okay, we can solve that particular part. Okay, just to be on a safer side, so I'm going to solve this equation. So your equation was 2x1 plus 5x2 is equal to 16, and they are given us x1 is equal to 5. So I'm substituting that. So instead of x1, I'll write here 5. So we'll be able to get the x2 ka value. So it will become 10 plus 5x2 is equal to 16. Okay, plus 16 when it goes to the other side, plus 10 when it goes to the other side will become minus 10. So it will become 16 minus 10. So 5x2 is equal to 6. x2 is equal to 6 divided by 5. So x2 is equal to 1.2 when you divide it. So if x1, therefore x1 was 5, so our x2 is 1.2. These are the point of those intersection coordinate. So I'll write this, B ka coordinates are 5 comma 1.2. So once we have got that, our final step is to get the value. Okay, so I'll write here maximization function was z is equal to 2x1 plus 10x2. So now the coordinate first is 0. Okay, where the coordinates was 0 comma 0. So 2x1, so 2 into 0 plus 10 into 0, the value is 0. For A, the coordinate was 0 comma 3.2. So 2 into 0 plus 10 into 3.2, that is 32. B ka value is 5 comma 1.2. So 2 into 5 plus 10 into 1.2. 2 5s are 10, 10 into 1.12, 10 plus 12 is 22. And last C ka value was 5 comma 0. So 2 into 5 plus 10 into 0. So 2 5s are 10. So from here the highest value is 32. So therefore the optimal profit, that is max z is equal to 32. Okay, and that's it. Last man, at point B where at point A, this is at point A where x1 was 0 and x2 is 3.2. That's our final answer. Okay, so this is how you all had to solve the sum based on LPP graphical method. You all can go through it once. Okay, now let us see one last sum for this particular video where we are going to solve question number 2. Okay, let us see. Okay, the question reads as a sales manager has to assign salesmen to 4 territories. He has 4 candidates of varying experience and capabilities. The manager assesses the possible profit for each salesman. So they're giving you S1, S2, S3 and T1, T2, T3. Then they're giving you find the assignment of salesmen of the territory to so that total profit is maximum. This is a maximization sum based on assignment. So let us see how to solve this particular sum. Okay, whenever sum is based on maximization, the very first table that you'll have to create will be called as a regret table, where we have columns T1, T2, T3 and T4, and here we'll have S1, S2, S3 and S4. In a maximization assignment sum, the first step is try to find out the maximum value in the entire question. So if you look carefully, the maximum value is 40 in T4. You can see that's the highest value. No numbers are bigger than 40. So now you pick up the highest value and you subtract it from all other values. So basically it's like 40 minus 35, we get it 5. Okay, 40 minus 27, we get the value as 13, and so on. Okay, then we have 28. So 40 minus 28 is 12. So we write the value as 12. Okay, 40 minus 37, 3. 28. So 40 minus 28 is 12. 40 minus 34 is 6. Okay, 40 minus 29 is 11. 0. 35 so 5. 16. 8. 33 so 7. 24 is 16. 8. 15 and 12. So we took the highest value, which was 40, and then we subtracted with all other and we got this new table. After making that, the second step, we need to find row minimization. Row minimization, again table remains same, T1, T2, T3, T4, S1, S2, S3, S4. Each row wise, pick up this lowest value and subtract from all other numbers. So the first lowest is 3. So 5 minus 3 is 2. 10, 9, 0. In the second, the lowest is 0. So every value will remain as it is. Third, mein 5 is the lowest value. So 0, 11, 3 and 2. 8 is the lowest. So 8, 0, 7 and 4. Step 3, column minimization. So same thing we will now solve how we did for row. Now we have to go column wise. Okay, same way, T1, T2, T3 and T4, S1, S2, S3 and S4. Column wise, the lowest value minus with all others. So here 0 is the lowest. So all the other values will remain as it is. Here the lowest is again 0. Values remain as it is. Here 3 is the lowest, so 6, 8, 0, 4. Here we have already 0. Okay, now from here we have to be a little careful. Okay. Now we need to do the crossing, so I will get the pencil. Okay, once you all have done with the regret, row minimization and column minimization, the next step is crossing the zeros out. Okay, so for that, in order to cross out, there's something called we'll have to cut the lines. Okay, so start cutting the lines, okay, row wise or column wise. Okay, we are trying to find whether it is optimal or not. Okay, so you start cutting all the rows and columns which has multiple number of zeros, and thereafter only 1 zeros. Okay, If the number of line matches the matrix size, then it is optimal, and then we can go further. So first see, I can see column wise there are 2 zeros here, crossing it out. I can see again in row wise also 2 zeros here, I can cross it out. And there's this just individual one more zero available, so I will cross it out too. So now if you look here, number of lines 1 2 3, 3 lines, but the matrix size is of 4 by 4, so it is not an optimal solution. So if it is not optimal, we'll have to make it optimal. So we'll have a new table here. Now see how we go about in making the new table. Again S1 S2 S3 S4. The rule is from the non-allocated, the non-marked, okay, non-cut values, which is the lowest value, 2. So the rule is you have to minus 2 with all the non-allocated values, and where the lines are intersecting, add 2 to that. So first 2 minus 2, 0, 12 minus 2 is 10, 8 minus 2 is 6, 6 minus 2, 4, 6 and 2. Wherever the lines are intersecting, add that lowest value. So this 11 will become 13, the 2 will become 4. Rest all values remains as it is. So 0 0 remains as it is, this 0, this 4 remains as it is, 10 6 0 0 remains as it is. Okay, now just to confirm, check how many number of lines can be again made from this. So one cross went off. Okay, I can see 2 rows here, I mean 2, so the row can get cut. I can see here again 2 zeros, I can cut this out, and this is single left out 0 which I can cut here. So now if I count, the number of line which I was able to cut was 4, and it is a matrix size of 4, so it is now an optimal solution. So let us make the assignment. So now we make assignment. In making the assignment, we only have to note down the zeros. Okay, the zeros are very important. So we first only take the values of zeros. In the first case, there is 1 0 here, 1 0, all the zeros. I'm just noting down wherever all the zeros are possible. Okay, now row wise, we'll go row wise or we can go column wise, but first you have to only select those zeros which appear only one time in that particular row or column. Now see, for example, in this column, in this row there are 2 zeros, so I cannot cross it out. In the second row there's only 1 0, so I will use that. The moment I use it, in cross all other zeros get cut off. Next, again 2, I cannot use it. S4 is only 1, so I will take that. Now we go column wise. There are 2, I can't use it. Here there is already used. This is only individual, so I will use this. So this goes off. So that's the only one remaining. So every row has or column will have only 1 0 which is marked. So it means our assignment is optimal. So final answer to find the optimality, S1 T1, take the original value from the question. S1 T1 ka value 35, S2 T4 is 40, S3 T3 is 32, and S4 T2 is also 32. The total comes to 139. So the answer for maximum assignment ka value is 139. Like that is the profit. Okay. So this is how you all have to solve question number 2D. Okay, chalo. So I hope everyone have understood the first 4 questions in question number 2 under this particular question paper. So with that, we will be ending this video here. Thank you.